Hello everyone, welcome back to my YouTube channel. Today we're going to be learning about the law of cosines. This is a very handy tool that will help us solve for different parts of a non-right triangle. Let's jump right in. So the formula that you see on the screen is known as the law of cosines. You can manipulate this formula so that you are solving for any part of the triangle. Basically, the unknown side squared equals the two known sides squared minus 2 times the value of the known sides times the cosine of the unknown side. You can also see a picture of a labeled triangle. Of course, not all triangles that we are going to be working with today are going to look like this specific acute triangle. Some triangles may have an obtuse angle, others may have 2 equal sides, and so on. But the main idea is that all of the problems we're going to solve today with the law of cosines are not going to include right triangles. I'll keep the formula up on the screen the entire time so that you can reference it as needed. Let's try to solve some problems now. In this first problem, we can see that we are asked to find the length of side C. If we look at our formula, we can see that the one gives us in the terms of C. So now all that is left is to plug in the values that we are given into the equations to solve for C. So we're going to have C squared equals 6 squared plus 7 squared minus 2 times 6 times 7 multiplied by the cosine of 20 degrees. If we put all of that information into our calculator, our answer comes out to approximately 6.06. But we are not done. If you look at the formula, you will see that this equation actually equals C squared. So we need to square this answer to get the final answer. So the square root of 6.06 approximately equals 2.46. Our second problem is similar to the previous one that we solved. However, this time we are told to find the length of A. We can use a different variation of the formula that we have already to find this. So let's plug in the values that we know. The way that we would change this formula is so that it says A squared equals C squared plus B squared minus 2bc times the cosine of A. So let's plug in the values that we know. So our A squared equals 30 squared plus 15 squared minus 2 times 15 times 30 multiplied by the cosine of 140 degrees. If we plug all of this into our calculator, our answer comes out to about 1,814. We will now take the square root of this answer to find out that our final answer equals 42.6. So the length of A in a triangle where the length of C is 15, the length of B is 30, and the cosine of the angle A is 140, the length of A is about 42.6. In this next problem, we are not told which part of the triangle to solve for, but rather told to solve for the smallest angle in the triangle. Now, before you go and solve for every angle in this triangle to figure out which one is the smallest, which, by the way, would be a waste of time, let's think logically. Look at this picture of the labeled triangle. You can see that the side of the triangle is opposite of the same lettered angle. So it would be logical to conclude that the longest side has the longest angle. You can see this even more clearly in the obtuse angle that is now on the screen. So knowing this information, we can say that since side A is the shortest, the smallest angle is going to be angle A. Now all that is left is solving for angle A. Now, with the formulas that were given to us, there is no formula that solves for the measurement of angle A directly, but we can manipulate the formula so that it says the cosine of A equals B squared plus C squared minus A squared, all divided by 2 times A times B. When we plug in our numbers that we are given to us, we get that the cosine of A equals 30 squared plus 40 squared minus 13 squared divided by 2 times 30 times 40. This equals approximately 0.9713. Use the inverse function key on your calculator and you will find that the cosine of 0.9713, which is also the measurement of angle A, is approximately 13.8 degrees. So, the smallest angle in a triangle where the length of one side is 13, the length of side B is 30, and the length of side C is 40, is going to be angle A, which measures at 13.8 degrees. Now we are going to solve some word problems involving this concept. The first problem states this. A ranger in an observation tower can sight the north end of a lake 15 kilometers away and the south end of the same lake 19 kilometers away. The angle between these two lines of sight is 104 degrees. How long is the lake? For simplicity's sake, let's draw out where the point ranger is, here, and name it letter B. From point B to point A to the north, we know is 15 kilometers. And from point B to point C in the south, we are told is 19 kilometers. The measurement of angle B is 104 degrees. Remember that we are trying to solve for the length of side B, the distance between the 2 points. Since this is angle B, the length across from the angle will be known as side B. So we are trying to solve for this length here. We know all of the information that we need, so now we just need to plug it into our formulas. So I will do this up here. B squared equals 19 squared plus 15 squared minus 2 times 19 times 15 multiplied by the cosine of 104. If we plug all of this into our calculator, it comes out to about 723.9. However, we need to take the square root of this, so our final answer is going to equal about 26.9. So we know that the length from this point here all the way over to this point is about 26.9 kilometers. The last word problem we are going to solve today says this. A baseball diamond is a square 90 feet on each side. The pitcher's mound is 60.5 feet from home plate. How far is it from the mound to first base? Let's start off by drawing a diamond and labeling each side as 90. Let's name this point here as B. We know that from point B to point C, somewhere in the middle of the diamond, is 60.5 feet. We can do simple math to deduce that with the measurements that are given to us, the pitcher's mound is not in the middle of the diamond, so we are not dealing with a right triangle. However, we can see that the angle created here at point B is a 45-degree angle since the line goes straight down. We are trying to find the distance from point C, which is right here, to point A, or otherwise known as line B. Just as a reminder, we know this because this is the side opposite to point B, which we labeled earlier. We now have all the information that we need to solve this problem. Just as a reminder, we know that each side of the baseball diamond is 90 feet long. We now have all the information we need to solve this problem by putting in the info into the equation. So 90 squared plus 60.5 squared minus 2 times 90 times 60.5 multiplied by the cosine of 45 equals 4,059.9. We will take the square root of this answer, which gives our final answer at around 63.7 feet. So we know that the length from point A to point C is about 63.7 feet. Thanks for joining me for another math tutorial. I hope you learned a lot and I look forward to seeing you in the next video.